Here we go into some practice of using the basic rules of integration. So we learned in the previous video the actual basic rules. Now let's put them into action. So find the indefinite integral of each. Check your solutions. I'm not going to check every single solution, but I'll show you a few of them, how that just literally means take the derivative of your answer and see if you end up back where you started. So the integral of 4 dx. I think the easiest way to do this is say the derivative of what gives me 4. So the derivative of what gives me 4? Well, that would be 4x plus c. That's it. That's your indefinite integral. Here's your check. Take the derivative of that. So you're literally doing d by dx of 4x plus c. And the derivative of 4x is equal to 4. The derivative of any constant is 0. That checks with this, the integrand, therefore we're right. All right, into this one, here we go. We're going to use the power rule on this one. We're going to use that a lot here. So that 5 can just kind of chill out. I think it's a little harder to figure this one out, saying the derivative of what got me here. So what we do is we basically do the power rule backwards. We're going to add 1 to that x. So you're doing x to the 1 plus 1 all over that new number of 1 plus 1. Plus c, that simplifies to, well, this is going to be a 2 down here. 5 over 2, x squared plus c. And that's it. That's your answer. Now what you'll see is when you take the derivative of this, that would be 2 times 5 halves x plus 0. The 2's cancel, and look what you're left with, 5x. All right, so that's your check. All right, I'm not going to check any more of them. You take the derivative of your answer and see if it matches with your integrand to check. All right, part C, more power rule. We're going to do that with 3 separate occasions. So here you're essentially just saying what's the antiderivative of that, of this, and of this. You're separating them into pieces. So here, again, I'm going to add 1 to 2. So that's going to be 3x to the 2 plus 1 all over that 2 plus 1. That's it. Minus, we'll do the same thing here. That's x to the 1. So it's x to the 1 plus 1 all divided by that new value. Again, I'm using this rule. The power rule is x to the n plus 1 over n plus 1. That's my antiderivative. Now, from here, I've got the derivative of what gives me 6. Well, that'd be the derivative of 6x. If you really want to, some teachers teach it this way. They teach it as x to the 0. They add 1 to that and do 0 plus 1 in the bottom, and that gives you 6x. I'm on that. I'm not a big fan of it, but it's all good if you do it that way. Plus the constant of integration, always got to remember that. C, we simplify it and you get 3x to the 3rd all over 3. Ooh, that's going to cancel. So those values cancel out. Nice. And you're left with x cubed minus, this is x squared over 2, or 1/2 x squared, however you want to write it, plus 6x plus c. And certainly if you were to derive, ooh, that is not good looking right there. If you were to derive this x, that x, you'd get 3x squared. The derivative of this, the 2 comes out front, and the 2's cancel, minus x, and then this is 6. And that goes to 0. Sweet. All right, the trig functions require you to know the derivative of trig. So the 12's just chilling out. Right? Literally, a lot of people will do this. You can factor out that, if you want to be formal, that coefficient. We could have done that with the 5 here as well as the 4 there if we wanted to. So the derivative of what gives me secant squared? That's tangent. So this would be 12 tangent x plus c. That's all. 12 tangent x plus c. That's our answer. All right, let's keep going. The integral of sine of x. We're saying the derivative of what gives me sine? Well, I know the derivative of cosine of x, we're going to have a plus c, that would give me a negative sine of x. I don't want negative sine. I want the derivative to be positive, so I'd have to put a negative there. And that's because, and we'll do a check, if I take a derivative of this, you got the minus 1 hanging out, and then you've got the derivative of cosine, which is minus sine x. The minus is canceled to give us the positive sine x back. All right, last but certainly not least, the integral or antiderivative of that juggernaut. Take it a piece at a time. So 2x cubed, that we're going to add 1 to, so you get 2x to the 3 plus 1 all over 3 plus 1. Okay, that's term number 1 down. Minus 2/5 is just chilling. This is going to be x to the 2 plus 1 all over 2 plus 1. Whatever that power is what the denominator becomes. Plus 7. This will be x to the 1 plus 1 all over 1 plus 1. Nice. Minus, and this will just be 14x, and don't forget about your constant of integration. C is for cookies, as one blue furry friend on Sesame Street once said, but it's also for constant of integration, and both are good enough for me. Okay, anyway, we've got this to simplify down. So you've got now 2x to the fourth over 4. The 2 over 4 simplifies to 1/2 x to the fourth. This becomes a 3 times the 5 in the denominator is a 15. So that's 2/15 x to the third. This will be 7/2. 7 over 1 plus 1, x squared, minus 14x plus c. And that's all we got. Not so bad. Okay, we're going to go into the second kind of problem here now, which I like to call the rewrites. And I always say manipulate before I integrate. So when doing an indefinite integral, we need to remember that it's all about rewriting sometimes the indefinite integral so it's in a position where we can actually integrate the thing. So check this out. We don't like how that looks. I'd rather it be in this format, x to the n. So this is going to be negative 10 x to the negative 4. That puts us in a position to use that power rule. Remember, the power rule is x to the n plus 1 over n plus 1. Now, I'm not going to go over it in the step-by-step fashion I did at this point like we did last time. Just keep in mind we haven't integrated yet. Negative 10 is hanging out. You add 1 to this. That would be negative 3, because negative 4 plus 1 over that power that you just got, plus c. A lot of teachers are going to want you to get rid of that negative exponent. Negative 10 over negative 3 is 10 thirds, or 10 over 3, x to the third, because of the negative exponent goes into the denominator, right? Plus c. There we go. All right, this one, we can rewrite that as x to the 1/2. Get it in that exponential form so we can use this. Now we're going to add 1 to 1/2. 1 plus 1/2 is 3/2. And we're going to divide by that number that we just got, that 3/2. That's plus c. Now, let's simplify this down a little bit. This is going to be, when you divide by 3/2, it's the same as multiplying by 2/3. So that's 2/3 x to the 3/2 plus c. And if you were to differentiate this, you'd see 3/2 times 2/3. They cancel. They're reciprocals. And you're left with x to the 1/2, which is that. I'm going to leave it in exponential form. Some teachers might have you write it as the square root of x cubed, right? But I'm going to leave it like this. Okay, now, something where you have a product to take. By all means, take the darn product. So I'm going to distribute here and get it again into a position where we can use the power rule. So that's going to be the integral of x to the third minus 6x. Okay. Now, from here, what we're going to do is we'll integrate each piece. So I add 1 and divide by that number that we got. So x to the 3 plus 1 is x to the fourth. Divide by that number. Minus 6 is hanging out. We add 1 to, this is x to the first. That becomes x to the second over 2 plus c. And when we simplify it, you'll get 1/4 x to the fourth minus 3 x squared plus c. Not bad. Okay, now this one right here is kind of gross. We got the cube root of x down there. We can rewrite that as 7 over x to the 1/3. But it's still in the denominator. So I'm going to rewrite it, and you can do it in one fell swoop if you like, as 7x to the negative 1/3. Now we're in a position to use this reverse power rule. So I add 1 to this. 7's chilling. 1 plus negative 1/3 is x to the 2/3. I divide by that power that we just got over 2/3, and that's going to be plus c. Well, if you're dividing by 2/3, that's the same as multiplying by 3/2. So I'm doing 3/2 times 7 x to the 2/3, which is going to end up equaling to 21/2 x to the 2/3. Don't forget about that plus c. All right, 2 more. Here we go. I know you got it in you. F's actually not bad at all. E is a special one. When you go to do E, it's a very interesting one. As I said, it's a special one. So we've actually got this division here that can be distributed. And remember, our goal is to put everything in this exponential form right there so we can use the power rule. So this we're going to split up as x squared over, and I'm going to put that as x to the 1/2. You'll see why in a second. Minus 3x all over x to the 1/2, or 1/2, dx. Now we're going to break this down. Remember, we haven't integrated yet. X to the 2 over x to the 1/2, we subtract exponents as x to the 3/2. Minus, we got that 3 to bring down, 3x over x to the 1/2 is x to the 1/2, subtracting 1 minus 1/2. That's dx. Now we're ready to integrate. So we add 1 to 3/2. It's in this form. We're good. That's going to be x to the 5/2. We would normally divide by 5/2.
That's the same as multiplying by 2/5. Minus that 3 is just chilling. We're going to add 1 to this. That's x to the 3/2. And then we normally divide by 3/2, so I'm going to multiply by 2/3. And then you got your plus c. Let's simplify it down a little bit more. 2/5 x to the 5/2. The 3's are going to cancel. And you're going to be left with minus 2x to the 3/2 plus c. And as I said, this one's not so bad. You got an invisible 1. A lot of people have some trouble with that one, but you put the 1 there and you're like, the derivative of what gives me 1? Well, the derivative of x plus c gives me 1. And that's it. Did some nice problems with some basic power rule on the slide before. And then in this one, we hit up some rewriting. You got to manipulate before you integrate so that you are set to use that power rule. See you next time. Peace.